my God, I'm an idiot. I was literally presenting to myself for half an hour. I talked about so many things. I can't believe I did that. I answered your question, Kaiser, in immense detail. I was curious. I assumed you'd left. I was like, okay, that's totally fair. Well, that was real dumb. That it just seemed like that's really disappointing. Oh, I've been doing this for half an hour. I started right on time too. I was like, okay, no one's chatting. There's like 7 people here. There were 7 people here waiting, and I think I was noticing everyone leave. I was like, oh, why's everyone leaving? And then I noticed I wasn't streaming. And yeah, that's so stupid. Yeah, I don't know. I think it might be just gone to the ether. But I'll start now. I'll start again. And let me just share on the thing that I posted that I'm a fool. And try to see if anyone will return. But then I'll continue. And I could summarize much more briefly. So let's see, doing this again. I was having such a good time too. I was making jokes. I was really feeling myself, as they say. I was feeling comfortable. But of course, I screwed up. I'm learning trial by fire how to stream. So I was streaming for 30 minutes to myself because I forgot to hit the go live button. Oops. Come back. Oops. Starting now. Okay, so now I have a lot of practice at this, yes. Every other time I did it, the stream thing, I'm not sharing the stream stuff, but it would start exactly when I clicked the button in my streaming software, but this time, because I scheduled it with that nice waiting interface, I had to press a button. And I forgot about that, and I didn't press the button. So that was real dumb. So let's just begin again, and I'll go by way faster. Okay, so you asked me, Kaiser, because you might be the only one. Oh no, some people are coming back, but you asked me about why Rust, and man, did I give you a thorough answer. And I'll sort of summarize all my notes here, which aren't going to make any sense, probably. But let's see. This is kind of like my history of programming. I started with Ruby on Rails back in the day, and then went to this language called Elixir, and then I learned Elm, and then I learned Haskell, and then I learned Scala, and then I learned, Swift was sort of in there somewhere. And I've, of course, also did a whole bunch of JavaScript things as well. And if you notice a pattern there, there are all these very high-level, sometimes functional programming languages, sometimes immutable. Definitely, they touch a broad range of programming features, but they're not C, they're not C++. And nowadays with these newer languages, they're not Rust and they're not Zig. And so I've gotten a good spread of language features across this domain of like, convention over configuration, omakase, developer happiness, Ruby, and then the crazy OTP actor-based Elixir thing, and then Elm and Haskell, which is just mind-blowing, white space function application. You can call a function without parentheses or commas. Like, how does that work? Does that violate the laws of physics? I thought it did back when I learned it. But then you learn about by sort of giving your brain the stereoscopic view into what's possible just by seeing programming from all these different perspectives. It's just really helpful. Like every time you learn something, especially the weirder, the more different it is. That's why people say, like, learn Haskell because it'll bend your mind and it'll make you better at all the other languages. And Haskell only does that because it makes so many novel decisions. Most languages are like in this C style with braces and curly braces and whatnot, and they're imperative and they're eager and they're sometimes high level and not functional and mutable. But Haskell is like lazy and it's in this ML style and it's purely functional. So it makes all these crazy different decisions, and you just get to sort of learn about that whole part of the state space of programming languages. And what's, it shows you a little bit of the core that by diffing it that many times, you get like, what is programming really under the hood? It gives you an intuition for that. So I just like learning new languages, and that's a little bit why Rust. Obviously, there's also been a lot of hype lately, and I'm missing out on sort of that low-level experience. So I want to get a little bit of that, and also just the hype seems cool. Also, it's a modern language. I think that was the last point I made. It was designed recently, and people love it. People are using it to build things that usually they would use Ruby on Rails for, which is kind of troubling for those companies. I'm like, really? That's crazy? Because you don't need if you're making just like a web appy app thing, like a Ruby on Rails thing, you don't need to deal with garbage. Like garbage collection is a blessing. You don't need to deal with a borrow checker. That's what BC stands for. You don't need to deal with all these different type wrappers that you have to do in Rust. So, but people are doing it anyway because Rust does a lot of things really well, like documentation, like tooling, cargo, etc. And I just kind of want to feel some of that, like what it does well, the simplicity of it, that you only have structs and enums, and there's not 1,000 ways to do things. Like there's no classes. Like I love Scala 3. It's my favorite language because it just makes you feel like a wizard, and you could do 1,000 things in it. Every paradigm, you could do object-oriented, you could do functional. You can really bend the language to your will. It has an incredibly powerful type system, basically as powerful as Haskell's, more powerful in certain ways, less powerful in others. But it really is hard to learn, and it's sometimes frustrating because it has so much baggage and there's so many different things you can do. There's no idioms in Scala. And Rust is very opinionated, very driven towards this purpose of being accessible, yet very performant and fast and whatever. And it might not be the right thing for every situation, but that's why. That's kind of a recap of my answer. I definitely said it more elegantly the first time, I promise. This is like that Tenacious D song now. This is a tribute to the 30 minutes of live streaming where I was really doing quite well, that just didn't even record locally. They're just gone. But that's okay, because one day the sun will go supernova and dissolve all memories. So anyway, the goal of this today is to build a SwiftUI style DSL in Rust, because I like SwiftUI a lot, and I think its Vue DSL is my favorite. In the last couple of live streams, I started building this little application for a little CLI tool for basically cross-linking Jira issues to GitHub pull requests. So you can, make a branch. You'd write some CLI command. It would find all of your Jira or GitLab or linear issues. You can create a branch for one of those. Just create a new branch that had the name of the issue and maybe / some description. But then when you were done with that, you would hit the M key, and it would open up a merge request for that branch and cross-link to your issue tracking system, the pull request MR, and like comment with the link to the issue. So just cross-link everything. And if you had multiple, if you were working on this across multiple repos, so like a front end and a back end, it would cross-link all of those MRs, open them all up at once. I built that long ago in Haskell, and it seemed like it was a fun project. So I'd like to do it again in Rust. Because Rust is one of its advantages is you can build binaries that run everywhere really easily. So it got really great distribution for CLIs, and they're really fast. And Scala, my favorite language, doesn't really do binary CLIs very well. And same with Swift. It's great for making UI apps, but I mean, it probably is okay. I don't know. I've never really tried it for that. Doesn't seem like a strength of it, but maybe it is. And so I was going to do this, and I started working on that a little bit, and I have some logic for doing that, and I tried to make some services that would do that. Just try to explore Rust a little bit, and I got somewhere, but it was getting a little boring, and I didn't feel like just writing a whole bunch of interfaces into different ticketing systems and figuring out their APIs. It's not like fun work, and it wasn't very interesting for learning Rust. But then I got to the point where I sort of used an off-the-shelf library for terminal UI called Ratatouille, which is very cool. However, this is their DSL for building terminal UIs, and it just doesn't spark joy, as they say. It's kind of, it's not imperative exactly, but it's not SwiftUI, that's for sure. Kind of awkward. You add things to other things, and it's just very verbose seeming. And I was hoping for something more Swifty, and I'm not even sure if that's possible. I think it is. I did a little bit of research. It looks like there's some experimental libraries that are doing stuff like that, but none for the terminal. So I was thinking of getting into that, which is a little more low level and maybe where Rust is better situated. Oh, hello. Hello, folks. Hey, Yash. Hey, Yassine. I hope, apologies if I'm brutalizing anyone's name pronunciations. Do forgive me. But welcome. My YouTube chat tracker just went to sleep, so stay awake. Stay awake, computer. Okay, cool. So yeah, that's what I want to replace, is this. And yeah, so and also part of the context here, I was streaming to myself for 30 minutes because I forgot to click the go live button. And so I very eloquently went over most of this already. So this is a good second practice run. It should be better, if anything. So far, more efficient. So yeah. So in case anyone's not familiar with SwiftUI, which is sort of my target API, apex of front-end DSL here, it looks sort of like this, without the comments, of course, where these things are vertical stacks and horizontal stacks. And in Swift, it's very nice. They have this special syntax, this builder syntax, where you don't even need commas between new lines. The new lines are sort of just pretend they're commas here. It's declaratively constructing this UI tree. And this would render something like this. So the vertical stack renders these things vertically. Horizontal stack would render things horizontally, potentially with some spacing between them. Hence, I had this spacing of 5. The space between 1 and eggs would have 5 between them. And there are all sorts of combinators where I could add padding to this, and then that would look very weird here. And one might imagine you to have a bordered, and then this whole thing would become, hopefully AI is smart enough. Let's check it out. Let's see. Wrap this in an ASCII border. Please, 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 please. Cool, sexy. So yeah, that would be very fancy. Yeah, so SwiftUI versus Rust. So basically, I like SwiftUI syntax for building views. And at least in this one library, for this terminal UI, this does not make me excited. And so I was thinking of taking a sharp turn off of the previous path, which was building this CLI application for doing issue management, and to actually rewriting the view layer of this library, or making an alternate view that could write into the same underlying stuff. So the way Ratatouille works is you build these views, and then the rendering, though, is done basically through this buffer, which is basically like a screen buffer. You can think of it just like an array of every character in every position on the screen, a 2D matrix of every character position. And it just writes those, whatever you did here in that view, to that buffer representing your current terminal window. And so really I could just not use their view library and write to that buffer myself, or we can create our own buffer for fun and just sort of be inspired by Ratatouille. Oh yes, let me another question. Let me see. Are you making a SwiftUI DSL using Rust macros or a SwiftUI parser? So yeah, totally different actually. Unfortunately, this is only inspired by SwiftUI. So if you're into my SwiftUI stuff, we're not actually going to be executing any Swift code. It's just fully going to be in Rust. We're basically going to be trying to emulate in Rust a Swift DSL. And this is a way of learning Rust for me, because I don't know it very well. I've just been poking around at it for a couple days and read some blog posts, and I'm going to be relying on AI and my knowledge of other languages to hopefully fill in the gaps and see where we can get. So that's kind of the plan. And However, if you do like SwiftUI, we are going to be re-implementing their algorithm for the most part, except in Rust. But that's not the kind of thing you often do in SwiftUI, is implement SwiftUI because it already exists there. So that should be relevant if you're into that kind of thing. As I am, I do like SwiftUI a lot. And so what I also talked about back when I was streaming to myself. And oh, I'm so glad there are people chatting now, because before I was like, why? There's 7 people here, but no one's talking. It was because they were all in the waiting room thinking I was, had forgotten about them. So thank you for being here and asking questions. So I was going to talk about, I started building a couple of data types here. Did not get very far. But basically, we're going to want this view trait that represents all of our views, like text, like hstack, like... do I have a Discord or something? I have a Twitter, and you can DM me there. I think I have a Discord, but I'll have to find the... I'm more publicly accessible via the Twitter. But if you don't have one of those, just leave a comment on this video, and I'll try to post my Discord handle there. I forget because it has a number in it, so I don't exactly know which one's which. So, okay. So view. So yes, this is going to represent, either a text or an hstack or a vstack, and they all have some common powers. And I've learned a lot of this, by the way, via the Objective-C.io folks. They kind of re-implement SwiftUI and Swift, which is super interesting, and I've learned a lot from their series. So it's going to vaguely be probably a simpler version of that in Rust. So one of the core properties of these views is that they can be sized, or they can be probed for their size. You can ask a view, like text, hey, what's your size? And it'll tell you how big it is in some context. Like you can think of proposed being at the beginning the size of your terminal window. Like, this is as much room as I can give you. How much of it would you like to take up? That's kind of the idea here. And so I had a couple of examples for text. This is the view. This would be rendered to the screen, ideally. And if we called .size on it, this is what we would get back. So milk, obviously, would be a width of 4 characters and a height of 1. Because this is a terminal interface, we're not dealing with pixels, we're dealing with characters, which is a nice simplification. Though we also have to deal with rendering to a terminal, which is a very strange language. Probably not any worse than dealing with GPUs and metals and all that kind of stuff, or metal low-level rendering libraries. So yeah, that's how milk would work. And for a vertical stack of 1 eggs, which would render something like this, we would assume, it would have a width of 4 and a height of 2. So that would be the size we would get if we queried how big of a rectangle do you need to render. But it's a little more interesting than that because of this proposed size. So instead of just asking for like a concrete size, it's always going to be the size for that thing. By having this proposed size, it makes this method very interesting, and it makes it useful for laying out things in a variety of ways. For instance, as I kind of sketched out here, if I wanted to center something horizontally, like this is like a view node. This is my view that I want to render to the page. Text hello centered horizontally. Say our terminal was this amount wide. Then the renderer, once it had its hand on this view, it could probe it with by calling size with different proposed sizes, and figure out sort of the bounds of this view. Like, how flexible is it, essentially? First, it's going to say, hey, hello, or whatever. Let's call this view here. Hey, view. What if, will you fit into a tiny box? Like, are you very meek? Will you just get in this nothingness for me? Can you just not render, please? And it depends on the view. Maybe text would be like, oh, sure, yeah, you don't want to render me? Like, okay, yeah, totally. I will be crushed for sure. I'll get out of your way. I'm sorry for bothering you. Or, and then after seeing sort of how small it can get, it'll say, oh, and how much bravado do you? How confident are you? Would you like to fill all of infinity? And in this case, because we called center horizontally, it might say like, oh no, I'll take as much vertical space as you have to offer me, please. I will take all of infinity because I'm going to use all of infinity and then put myself in the middle of it. So thank you very much. But I'll still just need one height because I'm not also centered vertically. So that's the idea. If I didn't have center horizontally here, then perhaps it would be like, oh no, 5 is all I need. 1, 5, please. Thank you very much. So by having this proposed size argument, it allows the renderer, the parent view, to probe its children, figure out their constraints essentially, and then intelligently lay them out. So that's H stacks and V stacks will probe all of their children. That sounds really vulgar, but they'll probe all of their children and see just how sort of how to prioritize the available room to each child, and lay things out nice and evenly. So that's a key bit of SwiftUI's API that we'll need here on our view trait. And we could start with, I guess, just that. The other thing, though, that we'll need, probably in this case, is a render method, which would not quite take this exactly. I guess we might need a proposed size. This is where I'm going to sort of be thinking out loud. We're probably going to be rendering to some size. This is like be the screen size at the beginning. Not necessarily proposed in this case. And it shouldn't return a vec of string. It should also probably take one of those buffers. And it will actually not return anything, I don't believe, because it's just going to basically write itself into the buffer. So in this case, yeah, a very simple buffer would be a vector of strings. We're probably going to want to make our own type, but Ratatouille also has a buffer. So this is where we're going to have to figure out what actually should a buffer be. And maybe for now, I'll just focus on size so we can get used to writing some Rust, sketch out a bit of the type hierarchy here, and have some tests for just size to begin with. Just checking the chat. Since the child proposes its size to its parent, would text propose its size to center horizontally or to center horizontally to its parent? So yeah, it's more. I think the parents propose this call size on their children. So what's going to happen here when we call this is obviously not existent yet, but we're going to have this method on text that it just looks like a method here, but what it's actually going to do behind the scenes is, I guess I should keep that around there. Center horizontally will be a method that will actually wrap text inside of some other view. So it'll, I'm not entirely sure what we want yet for that. Let's just keep it simple and say we're going to have a centered horizontally view. We're probably going to have something more general purpose than that, like a frame with some settings for what kind of alignment and how much flexibility. I think that's kind of the SwiftUI way of doing it. But just simplifying it here, it would look something like this, where we have we're calling this method on it, but the implementation of that method is just going to stuff the left-hand side, stuff this self into some other view. And then when this other view gets the render method called on it, it will look at its child and propose a size to it based on how much room it has available, probably, but also it'll use these two methods to figure out just how potentially it might use these. It depends. Different views might not call this on their children. Basically, by calling these two sets of methods on the children, or calling size with sort of no space and lots of space, you get to figure out the bounds. But maybe centered horizontally doesn't need to know that about text. It just wants to know, okay, how much room do you want given? Like if there's only one child, it'll be like, okay, well, I have this much space. I'm going to give you like I'm going to propose a size to you of a width of however many characters this is. Looks like 21 characters and a height of 1. How much space do you want? And it'll say 5 because it's just a text node in there. 5 width and 1 height. And then it can use that information to figure out exactly where it needs to start rendering it from. Oh, if you're width 5, then I need to start rendering you here so that you're actually centered and not from here. And if you were like width 26, then I'll start rendering you from the beginning because you're some really long series of W's or something. Do you want to follow the same conventions in SwiftUI, like modify content text string? I don't think so. I'm not entirely sure. Well, one of the problems with SwiftUI, which I do love, as a user, but as a developer, I'm not entirely sure how those things are implemented, right? It's closed source. So I have a bit of a clue based on the Objective-C talks and other things that I've read online, but I really don't know the actual implementation. So I can't copy it terribly. And I've seen those types, but I don't really know what a modified content is exactly, what that's structured like. But yeah, I'm going to try to just figure out what makes the most sense, and it'll be inspired by it. But yeah, if you have some good ideas, let me know, and we'll plug around. But let's try to get something on the screen here. Let's try to get some actual code. So, I also made a size struct. So it has a width and height, and this usize is basically either a 32-bit or 64-bit integer, depending on your unsigned integer, depending on your system's CPU. So just the size of a pointer, basically, which is some low-level stuff you don't need to think about in other higher-level languages. Basically, it's just a number, an int of some size that's useful. And then I was showing off how you sort of make constructors. So if I did size dot zero, I'm not sure if I could just call this here. I'd need to do something like, what is it again? Let hello equals size dot zero. I just don't think I'm able to call this here. Okay, I am. Expected an item. Okay. Oh, static. Can I do static? All right. Size dot zero. Why am I not getting autocomplete? All right, this is a pain of because I need 2 colons, and this is not happy. Okay, I'm not supposed to do this here. Hey, thanks, Tim. I appreciate that. I'm glad you enjoy the videos. Hopefully this amorphous stream is also useful, but those videos take a lot of work, so they're probably more calorically dense than this exploratory rambling that I'm doing now. But I'll try to get back to making some of those, because they're fun as well. They just take a lot of time. And this seemed better for something that I actually don't understand yet. So let's see. So yeah, I have a size for proposed size, so just width and height. And I want to start making some of these other types. So let's see how to do that in Rust. Oh yeah, good question. So what is the ampersand self? So ampersand self, this is something else I talked about before I hit the go live button when I was streaming to just an audience of myself. So notice how this is, I kind of brought it back to the fact, if I remember what I said before, learning all these languages is very useful, because you get a sense of, it makes subsequent languages way easier to learn, because it's like, oh, that's just a little bit of that, that's a little bit of that. And that's how most languages are designed. Like they're just a sort of the designers are taking the best features of all the languages that came before them. And I'm not sure if this exactly is the best feature of any language, but it does remind me of Python. So in Python, when you have a method on an object and you want to say like, rect dot, you have some rectangle and you want to call dot width on it, the way width would be implemented in Python is like, let me cue the AI. Python would be def width, and it would take the self argument, and then it could call whatever self.size.width or something. So when you want to make a method on something, the first argument is that something. So size is going to be a method that we can call on instances of view. And notice how 0 does not have an ampersand self. So if I wanted to make a get width method here, that would take a self. And whereas, is there like a document? Generate documentation. Example. Look at that. Cool. Cool. So for a given size, we can call get width on it. And notice how you don't pass in size here. But actually behind the scenes, I think the reason why this is the case for so many languages, but certainly for Rust, is that behind the scenes, the compiler is going to rewrite code that looks like size.getWidth as calling some getWidth method that exists on some object that it creates, some static method, and passing the size along. And they're basically interchangeable. Like you can always rewrite any method on a thing to be like a free function that accepts that thing as its first argument. In other languages, they don't make you write this boilerplate. They just you just have implicit access to this, which is like secretly passed along by the runtime or whatever, or the compiler. But they went sort of the Pythonic route where you have to specify ampersand self for when you want to write a method on the thing. And I guess the reason why they did that is because both methods on objects and sort of just constructors or free functions can live in the same impl thing. Like, you're not defining it inside of the body here like you would in Swift or something. Yeah, I'm not making funcs in here. So they needed some, I guess, distinction between that, and that was the way they chose. So that seems reasonable. Just another variant of the same idea. Reading the chat again, sorry. I think I answered the ampersand self thing. Humor and high-level Swift content make more. Okay, I will obey. Yep, it's very Pythonic. I don't know any other languages that do that. I'm sure there are some, but maybe I've seen them and they're not coming to mind. Is an immutable ref to self while fn is a mutable ref to self. So what's the difference there? Oh, between the ampersand. So the ampersand in Rust is subtle, and I'm not sure if I fully can explain it perfectly yet. But you may have heard, if you've heard one thing about Rust, it's about the idea of borrowing, right? There's this thing called the borrow checker, which is super important and makes it fast. It allows it such that it doesn't have a garbage collector. It can just kind of figure out statically when to deallocate things based on who owns the value, and if the I can't fully synopsize it just yet, but I do know that if you see an ampersand in front of a thing, that means, oh yeah, it's been borrowed. So if you just have thing, that means sort of, I think there's owned, borrow, and you can also have a mutable borrow. So if you're borrowing something, you actually can't mutate it. You can't change it. So this is sort of Swift-like, where there is that idea of there are these immutable, sort of immutable data types, but you can mutate them in some situations, and you have to declare functions as mutating. So that's what that and mute thing does. But yeah, the difference between basically a thing and an and thing is whether or not you actually own the value or you borrow it, and still have to build my intuitions as to when you want to do one thing or the other. Most of the time, methods accept borrowed things or mutably borrowed things if you need to modify them. And I think self always has to be borrowed when used to define these methods, but I'm not sure about that. So just checking what you're saying. Sorry, I've got to get my chat closer to my monitor. I'll figure this out. So let's see. What happens if in Python you don't pass in self in a class method? Yeah, I have no idea. I'm guessing it just wouldn't work. I mean, it certainly wouldn't have a compiler error because it doesn't have a compiler. So it probably would just blow up in some weird way. And maybe it just assumes that the first argument is self. I would guess. I'm not sure if in Python you can just, like in JavaScript, pass as many arguments as you want and it'll only use the first that you've named. I'll have to explore that. So you borrow the ref to self using the ampersand. How do you consume the ref to self? I'm not entirely sure. I'm not entirely sure yet. But maybe I might be misunderstanding too. So feel free to ask more questions. And thank you for the questions. I really do appreciate them. And I should probably figure out how to get them on the video screen. But I think they'll be in the chat for everyone to see as well. I've got to get better at streaming, as I mentioned. I should probably watch some other streamers to see what good things they do, so I'm not just a comedy of errors here. Rule number 1. Oh, thank you. It sounds like we have someone who actually knows Rust has entered the building. So thank you, Stuart. Rule number 1 of the bar checker is that it is moved by default. Yes, and so let's just write some more code, I think. That'll get us, because we're not really in this situation where, so if I did say, let's make a example. So if I have a size, let size, and then I want to call let width on it here. We don't actually pass in the self to here. It just kind of does it automatically. So we don't have the option to not to pass it in a different way in this case. But I'm guessing, I don't know this for sure. Here's my big guess that I can also, can I get width like that? Yes, I can. So that's kind of what the compiler is rewriting size.getWidth into, I imagine. And notice how it's also adding us the ampersand there. If I don't have the ampersand, it tells us something. Consider borrowing here. I like how it's so generous. It's like, you might want to borrow here if you would like to ever run this program, I guess. But that's funny. That's very cute. So yes. What, any more details? Basically, they're different types, I suppose. Mismatched types. It needed a borrowed size. It doesn't want to take the size. It just needs to look at it. Please don't. It's like, dude, just let me look. Can I hold your baby? I don't want to adopt your baby, I guess is the idea. So that's interesting. Oh yeah, I saw that. Yeah. So hopefully this is useful for Swift too. I have not played with the new ownership things, but yes, they clearly are inspired by Rust in some regard. And they do have some, like, both being sort of modern languages, they've done some similar interesting things. This sort of mutability, copy on write mutability, which is kind of just their default in Swift with garbage collection, is something you can actually, so in Swift you can opt into this borrow checking, it seems. Maybe they've added that. But in Rust, you can opt into copy on write semantics. They have a wrapper, I believe, called a cow for copy on write things. I haven't used that yet. I've just seen it and seen some talks about it. The people who make the Z text editor have some pretty cool talks on Rust, and that's kind of one of the things that inspired me to do this. They have Z Industries as a YouTube channel, which is very cool. And I just posted a thing on Twitter that I watched from someone named Rafe Levin. I don't know, Rafe somebody. Rafe Levine, possibly, AI, made the Z logo. That's not true. I was hoping AI can help. Rafe Levine, I believe. Levian. Yes, it's very polite. Have you considered writing good code? Anyway, it's almost condescending, but I'll take it. So I will. I'll delete that for now. It'll be in the video. So okay, let's write some stuff. Let's get some more stuff that. Let's actually. I'm sort of pussyfooting around. I feel like that word is maybe not good to use, but I'm being coy. I'm avoiding the hard work of writing Rust here. So let's make some structs here. So I do want text. I know I want text, and sure, it'll have a string as content, and I know I wanted to implement the view. So that's how that works. Also very similar to Swift, actually, which is pretty interesting. In Swift, this would be, extension. And let's see what it does. So this does not care about the proposed size. It's basically going to say that, it's the length of the text. Makes sense to me. And a height of 1. However, I might want to do something like min proposed width. So whichever one is smaller, in case that seems to make sense. I probably don't want to draw the text off the available size. I'll probably truncate it from the left or something. Yes, is known uniquely referenced. Pretty fun. And basically, from what I understand, that's possible in Rust. There's this thing called an arc, which is an atomically reference counted. And arc is basically what Swift is all about. It's like its big secret. It doesn't exactly have a standard garbage collector. It uses automatic reference counting. So, which is basically just like if you have an arc of A, it's the thing, and then how many times it's been borrowed. And so the implementation of is known uniquely referenced is basically just checking, like, is unique, let's just say. This is just going to be fake Rust, would basically be is like count equal to 1. And then if you know that count is equal to 1, you can mutate the thing directly. And it's still going to look from the outside like an immutable data type. And if it's not uniquely referenced, then you clone the thing and then mutate it. So you get immutable data without the costs. of immutable data, which is copy every time, which in Scala, unfortunately, is copy every time, because it's a much higher level language with garbage collection. But that sometimes is a problem. Can an impl block add new properties to the struct or just implemented what's required? So in here, SpongeBob case, let's make a new method. Cannot work because it's not a member. However, which I kind of like, it's just like, oh, this is the impl for view for text. So just do the view methods, please. But you can have as many impl blocks as you want. And if you just want to add methods to the thing, it would be this. And I guess this is not correct. Let's. I'm gonna have it fix. I'm gonna have AI fix my SpongeBob case because I want to keep this method around. I always love having a SpongeBob case in my libraries, and I'm not sure unless it just gets angry at me forever. Rand does not exist. Oh, okay. Undeclared create rand. So let's add rand. This is very important. Create add rand. No, cargo add rand. Rand added. Boom. All right. So we'll test out SpongeBob case later. Actually, I want this to return a new text. So we should wrap the result in text. So I'll call this SpongeBob cased. Make it past tense to imply something important. But can you add the default impl for the methods? I think you can do a default impl for these things. I think I can. It seems to work. So I'm pretty sure yeah, that would be a default implementation there. And you can override it. I think. I'll have to figure that out for sure. Cool. So where are we? Where are we now? All right, so we have text. I added a pointless method here that I will use later on, I'm sure, for great fun. And then we have the size method for text. And then next, I want to implement probably eventually a render, but let's do like also an H stack or a V stack. Let's do a V stack. So a V stack, and I'm going to have it autocomplete. But this is where Rust starts to present challenges. Like in Swift or in Scala, in these higher level languages, you're not going to see this box thing. In Swift, Swift is actually pretty similar in a lot of ways. And when you do have traits, you do have to worry about, you don't know they both do this thing called monomorphisation. I think Swift is a little more complicated than that. I'm not sure exactly what Swift does. I should know. There was a talk I tried to watch about it once. I should figure that out. But basically, Rust likes to know exactly how big everything is. But because anything can become a view, like I can implement view for any type. Therefore, if I have a vector of something that implements views, well, they could be all sorts of different views. And one could be a 32-bit integer, one could be a string that's 1,000 characters long. So it can't make that nice array of like giving every item there the same exact size, so it knows how to like index in constant time into any position in the array, right? If you know that every element in the array is 3 bits wide, 3, 6, 9. Not sure if I'm doing. Not that 3 bits really, I don't think is ever used. It's always going to be some byte thing. And you want to go to the third element, right? You would just know that it's 0, 3, 6, 9. You would just take the width of the elements in your array and multiply that by the number you want to go to. So to get the ith index, it would be basically I times the size of the type in there. And so if you knew these were all, 3-bit things, which doesn't exist, you would just go to the 3 times 3 to get to the third element, or whatever. Or 3 times 3 minus 1, I guess, to get to the start of that. Anyway, but the problem is, obviously, if they're all different sizes, you can't do that. So if they're all random haphazardly placed, you would basically, to get to some element, you just have to sort of scan through the entire list. And you'd also probably need to have like some kind of other marker to know that it's like a different type and what type that it could be. So in most languages, you have to do something with like there's many solutions. Very high level languages like Scala just deal with that for you. Like you're never exposed to this stuff, and you don't have to think about this stuff. And it kind of does something like what you have to opt into in Rust. I'm going to look at the chat real quick because I've been rambling for a minute there. Okay, and yes, what's the box type and how and the dyn keyword? So yeah, that's exactly, great question. So this is the kind of thing that might be occurring for you. Like in Scala, if you have a trait, if I did trait view in Scala and I just had a list of view, you can do that. You can say list of view. And at compile time, you could have 37 different implementations of views, all with different arguments that'll all take up different amounts of memory and whatnot. But it's cool with that because it's going to use pointers and the JVM, and it's going to do virtual method calls and whatnot. And behind the scenes, basically what's going to happen is that each one of those views is going to basically just be a reference. It's going to be a pointer. And a pointer is always the same size. So a pointer, well, it depends on your machine, right? That's what that usize thing was. It's basically the size of a pointer on your machine, but it's either going to be 32 or 64-bit number. And that's going to be just a memory address somewhere in virtual memory space. It's going to be your address. If everyone lived in a box on the same road, that was all the same size. That's what a pointer is. And so because of that, it's really easy to find any one of those views because it's just going to be 0, 1, 2, 3, 4, 5, 6, 7. And the width of these are always going to be times these sort of the size of a pointer. So if you want to get the fifth view, you just in this list would be 4 times the size of a pointer, 4 times 32, whatever. And that'll be that memory address for that view. And that's just a pointer to some other place in memory. So then you could jump to that place in memory and ask that thing, hey, what are you? So the idea of box is basically put this thing, this is not going to be on the stack. It's going to be on the heap. Essentially, it's going to be a pointer to that thing. And I don't exactly, okay. Dyn is a prefix and I don't know, like I'm learning this myself a little bit, so I might be lying, and I hope that's okay. And we'll find out by hovering. Oh yeah, terminal UI, you got it. Like NeoVim, like LazyGit. I love LazyGit. If you've ever checked out LazyGit, that's like a top-notch terminal Git UI. Okay, where am I? So yeah, I'll learn more about these things. A dyn trait reference contains 2 pointers. One pointer goes to the data, and another pointer goes to a map of method call names to function pointers. Okay, super interesting. I didn't know that. So the combination of box and dyn are basically what allow the things that you get in something like an object-oriented language, essentially. Like it is going to turn into virtual method calls. It cannot know at compile time which actual view that is, so it's going to have to store that data in memory, and it's they're going to have to be pointers to other places so that they're all the same size. Yeah. But the really cool thing, yeah, I'm definitely selfishly learning by teaching. That's what this is. So, thank you very much. So, from what I've understood by doing some research in the past, is that, well, this is probably fine in our case. Like, this is whatever. Like, in Rust, it makes you feel very guilty and bad. Like, oh my God, what have I done? I've boxed and dined, like all the overhead. But this is like what every language does. And Python's implementation is probably like 1,000 times worse than this. So this is like, it's okay. It depends on your use case. And for terminal UI, it's probably okay. You're not going to have that much stuff on screen at once. But because I want to sort of explore what Rust can be really good at, there is this idea known as monomorphisation. And once again, I'm kind of hacking this is my regurgitated understanding of it. But if we had let's just imagine this. Like, let's just say instead of this V stack, because this is a little complicated, this is a bunch of children. Let's just say we had a padding node. So padding would just have a single child and a padding. And an example would be, text hello, text hello dot padding 3 should be Hopefully this works. All right, not quite. But let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. Cool. My Vim skills. This is like I'm failing. What is it? And the AI is not helping. What is happening? Why are there 8 of those? Help! Oh my goodness. Okay. Whew, that was so unnecessary to help this example, but there we go. That's padding 3 by 3. Don't even remember why that matters, but we'll eventually need that. So there, that doc string will live on forever. Okay. And so this is that same problem where a child, because it can be any kind of view, we're going to put it in a box and have some pointers that will point to the implementation and also point to a bunch of methods. I guess for all the methods on views, so it'll be 2 sets of pointers, I guess. So like if it's text, it'll be a pointer to this implementation of text, of size. And if it had other methods, it would have basically a pointer to those concrete implementations for whatever type that is. And it needs to be there at runtime because at compile time, it doesn't know what that is. I think that's the idea. But the very cool thing is that instead of implementing it like this, we can instead introduce a type parameter. I'll do v for view here, and I could just say this as well. And this is kind of like how Swift works, I think. For some reason, it's in my head that it's not quite like this in Swift, but when you're using it as a user, you get similar types. Anyway, I'm not going to ramble on about Swift at the moment, but let me make another method example. And if you can see here, I've constructed a padding, and in the type here, it says padding text. And what this means is at compile time, Rust knows that the text, that the view inside of this thing is going to be a text. And therefore, it knows how big a text is. Oh my God, it even tells us. That's pretty cool. That's kind of awesome. I don't see it for padding, because I guess it depends. That's kind of crazy. Can I see it if I hold on to view? Size 32, align 8. So yeah, this is size 32. This is size, what was that? Text was size 24. I don't know why that's 24, but that must be the pointer. So that must be something. I have no idea. But basically, it knows how big this thing is. And it doesn't need to do any boxing. It can just kind of like allocate enough room to have all of the data contiguously in memory on the stack or whatever, because it knows the exact type it is and all that stuff. So there's compile time information it can use, which is pretty cool. Yes, and it's very similar to the sum and any in Swift. So yeah, Rust and Swift actually, surprisingly, siblings. AI plus Vim, still unable to exit Vim. If you do a vec of box of views, can that only contain one type of view? I only an array of text. No. So for this case, you can have all sorts of types. So let's have a VStack example. So I can have one text, but I can also have a padding, which I'm not sure if I made padding into a view yet, so that won't work until I say impl a view for padding, and we'll worry about the implementation later. But the point is that'll work. So you can have any number of views here. And that's kind of the benefit of it. Oh, do you have to specify padding text, or can you just infer the type? Oh, you could just infer the type. And in fact, it is. This is not my code. This is it's a little weird. I don't know why it's so. I can't. That's ghosted in there. I've only written this bit. Woo, woo. So that's the compiler helping me out. I hope that makes sense. I'm going to keep glancing over. So yeah. The question would be, though, Okay, that makes sense for padding, and we can use that generic type there to propagate that size information and not have to box things up, which is also annoying when you want to actually use these things, because notice we actually need to create the box around everything, which is like, this is, I would just die. You never want to write this. And you can make some helper methods, but then you have to know, like, oh, you can't just create a text. You also have to box it up before you put it in this context. And it's just like a whole bunch of bookkeeping you don't really want to have to do. So I don't want to do that for a VStack either. And this is where it also is very similar to SwiftUI, or we can take a note from SwiftUI, and also some Rust libraries I briefly glanced at the code at to realize that this is possible. And instead, we want to be able to do something like this. That would be really cool. And let me try to just have another text note here. And so far, it works. So we don't have the boxing, yay. But notice it says text here. And so if I wanted to make one of these a padding node, well, it can't. It expected a text. They all have to be of the same type. That's kind of what that implies. And it's not that Dyn view thing. If you want to do I could do the box of the Dyn, but I can't just have it do that. And this is for that same problem where these have different sizes, and so it can't monomorphize. I don't know if monomorphize is exactly the right word here, but it can't know at compile time exactly the size of each of these elements. And so one terrible solution might be the following. Let's just say vstack2, and then it would be child 1 and child 2. And then let's change this thing to vstack2. Hey! And it kind of works. Obviously, this is an awful API, but at the type level, this is okay. And you could have a whole bunch of these. You just keep making them with boilerplate, or hint, Rust macros are generally used to solve these kinds of problems. You could just keep going vstack3, etc. Pretty awful API though. So those are two things that I would like to fix. And I believe SwiftUI actually does this as well. Not for VStacks exactly, but I believe they have a tuple view. And so instead of being a VStack, these are actually more of this thing called let me try to grab just the amount that I care about. I'm just going to rewrite it and let AI do it. That'll just be easier. Tuple view, or say a view tuple. I don't know, tuple view. Let's go with tuple view. And then there would be a tuple view 2, tuple view 3, or tuple view 2, I guess that would be. Okay. Let me just check. T1, T2 gives me nightmares. Yes, no, absolutely. Yes, it's kind of similar to that in SwiftUI. And to go back up to that thing, or wherever it went, the way this works in SwiftUI is that this whole builder block can and does behind the scenes basically construct something like this. Is not exactly a macro. You can kind of think of it like a macro. It is a compile time transformation. I think I did a video on the builder syntax. I forget. It's all a blur. And behind the scenes, it's going to instantiate a VStack with some kind of like tuple 3 view inside that will have an HStack and a text and a text. And it does, tuple 3 view does have those 3 parameters. And HStack is going to be of a tuple view of like tuple 2 of text, and so on and so forth for the rest of it. So it's kind of crazy looking if you look at the types sometimes. I think it's less verbose than this. It's been a while. And Rust, I do not believe has variadic generics, but that is sort of where macros come into play in the Rust world to solve for some of those problems. And there's some other ways around it. Yes. So the way we're going to get around it actually is, and I'm copying this from a library called, I believe, RUI? I was looking for like any kind of SwiftUI inspired UI, and I believe RUI sort of takes a SwiftUI approach, or very much does, though it's for general graphics, not terminal UIs. So it's not, RUI is not a TUI. So we're going to make the TUI RUI. Maybe that's a great library name. Yes, and now repeat each content. But behind the scenes, that is basically just syntactic sugar for essentially doing the same thing. I mean, it's definitely some complicated, crazy. Oof! I started recording a video on repeat each, but it was just very boring. And there's actually a really good Apple developer official video that one of the people who worked on it made. And I realized after recording my video that it was basically exactly the same thing, except theirs was better and had fancier, higher budget animations. So I never released it. The one true Rui. Trui. So we're going to copy their thing. And it's a little different than this, actually. Because it uses this is the idea that we're going for, though. Like we need to have something that's parameterized a different amount, and yay. But eventually we actually want to operate on these things and get access to each of their children. Like we want sort of the semantics of the fact that we just had it sure would have been nice if we could have just had a single vector array or whatever of a whole bunch of views of different types. But because we don't want the overhead, we're going to have to go through a whole bunch of crazy maneuvers. But at the end, when it's all said and done, we want to be able to call something like, if we have a bunch of views, we want to say like for each on each of them. We want to get them out to iterator or something. We want to be able to get our hands on essentially a vector of those underlying views, except in a more efficient format. And so the way we're going to do that actually is by, let's get rid of this. And get rid of everything, I guess, and make another trait called, this is what's going to be a tuple view. Or I'll call it a view tuple. I believe that's better, because it's actually not going to be a view itself. And I'm going to give it a method. This is copying from what I vaguely half remember from the other library, for each. And it's going to take there's all different kinds of. Basically, what this should take is, I guess, itself, whatever itself is, right? Because it's a method on the thing, and it's a method. Like if we think of a view tuple as basically thinking a morally equivalent to a vector of views or a list of views. And so, for each of these things, we want to be able to call for each, and give it a function which is written in this crazy syntax in Rust. I'll get used to it, but it's painful for now. And it gives you each of those views. You know, if this were Scala, it would be you get a view. No, it wouldn't be that exactly. And you can do something with it. But you get a view, and you want to call something. View ... And I believe, and if this were Swift, you can make a function of type view to whatever, to void or to thing. I write too many languages, so in Scala it would be something to units. Something like this. But in Rust, they have a different syntax. And I believe this needs to take an FN mute. Please? And that's quite horrifying. I don't think this needs to be a mute. Dyn fun FN mute? I think it could just be that. Oh, maybe it does. Trait objects must include the dyn keyword. Oh, no, you know what it needs to do? It needs to take an F. F is a fun mute. So that's like the crazier thing. Like, instead of just being able to specify a type signature here, you have to specify a generic that is the type signature, and then the function is the F. So this is vaguely equivalent for... Oh yeah, take care, Yash. Thanks for watching. Come back. I really pleasure talking to you. I'll probably end pretty soon, because this is my second time through it. Not this part. I didn't get this far. Bonsoir. So yes, theoretically, Yes, morally equivalent to in Scala, like def for each, yes, something like that, I guess. But there's all these crazy different semantics, and this is fn_mut can be called repeatedly, and it may mutate state, things that it might have captured, mutable references to captured variables. And I think that gives us flexibility to like count up things about these views. It can like, it's not mutating the views, but it can inquire something about each view and, update a count or something. So I could have something like a total width, but maybe I could even implement this by doing that. Yes, okay, it did it. So making a mutable total, then calling for each, and for each of those views, adding to the total its proposed size. Oh yeah, with I guess maybe I should have a max as well. I know I want a max constructor, please, AI. So just give me the largest max. Yes, perfect. I wonder if I can have like consts. Max, can I do that? Is that legal? Anyway, I'll just do max, but so where did it go? So yeah, I'll just propose the maximum size. And anyway, I don't want total width, but that's the idea that's the flexibility of for each. We can get other things from just iterating through each item. I'm not sure if that's the best or the most idiomatic interface. I'm surprised it's not like an iterator or something of dynamic views, because that seems to be the rusty way of doing things. But this is what I saw in the other library. And yeah, I mean, it's getting pretty late. So I might stop here. And then if you're interested at all, I'll do this again, maybe tomorrow. I don't know. To be continued. We will actually see what the hell this thing is about. And I swear I won't work on it in the meantime. So yeah. Thanks for watching, everybody. Thanks for stopping by, Yash and Stuart and Shandu. And who else was here? Tim. And then all the people who Kaiser. All the people who I ignored because I forgot to hit start stream. I won't do that next time. I'm scarred, so it learned one thing. Hey, all right, LB. 1B? LB? Pound? Keep lurking. Kaiser! All right. Well, thanks for watching all. Hearts. And till next time. Peace.